I'm Steve from Kiln AI, and this is Tools101, an intro to tools in the MCP protocol. It's going to be a quick way to get you up to speed on how to add tools to an AI system. I'm going to show you some examples of popular tools to give you ideas of sort of capabilities you can add to your system. We're going to look at what's happening under the hood when you make tool calls and what's added to your model's context. We're going to go over system design guidance for how to add tools effectively without overwhelming your context. And finally, we'll look at advanced next steps for things like evaluating tool use or fine-tuning for tool use. Let's dive right in. The concept of tool calling is pretty simple. Models can't do everything. A model trained 6 months ago isn't going to be able to tell me the weather in Toronto today. So we give it access to tools. The model can call out to these tools, get the information which it then reads, and continue on the way with its task. Let's look at some more concrete examples of real tools to get a better feel for this. All right, let's use our app Kiln AI to ask GPT-4.1 Mini a simple question and run it. And there's our answer. All good, right? Well, there's only one problem. It's wrong. LLMs are great at lots of things, but they're not good at math. So to fix this, we'll give this LLM access to tools. In settings, we can add a tool, select the basic math tools, and back and run, you can see we have a new set of tools available to the model. Let's give it access to these tools. And run the same problem again. Again, we have an answer, but this time it's correct. We can see that the LLM made a call out to the multiply function and used the actual calculator functionality to get the correct answer instead of just trying to use the model itself. That was a simple example, but let's look at some more examples. Back in settings, I'm going to add the Firecrawl tool, which gives the LLM the capability to search the web and read web pages. And back in the Run tab, we'll ask GPT-4.1 another question. This time, what are people in Hacker News saying about GPT-5? Now, it's not going to be able to get this because GPT-4.1 was trained before GPT-5 came out, and it pretty much says the same. However, if I give it access to the Firecrawl search and scrape tools and try again, it's able to actually go read the web and give us a summary of some of the comments being made on Hacker News about GPT-5. You can see it actually makes a call to the web search function and pulls back a bunch of information from the web to build that summary from. Let's try another powerful capability. Back in settings, let's try the Run Python code option, which actually gives the ability for the LLM to write and then run Python code. And I'll add another test that an LLM alone will have trouble with. And another wrong answer because the LLM alone doesn't have the capability of performing this task. But we'll add the Python tool call functionality and run it again. And this time it gets the answer correct. Let's look at how. The LLM actually writes a small Python program to calculate the answer, cleaned up version here. It invokes the tool to call that, gets the correct answer, and is then able to return the correct answer. Kiln has a bunch of cool MCP servers built in, which you can try out in just a few clicks. But you can connect any MCP server to Kiln. Just find a server that you want to connect. I like to use a directory like Pulse's MPC server directory. Click through the documentation and follow their steps for connecting an MCP server. In this case, we'll use the Notion MPC server to give the LLM access to an internal documentation. And now back in the Run tab, I can ask it questions that require it to search and read our internal Notion documents to get the answer. And there we go. And now let's look under the hood at how LLMs can make parallel tool calls for speed, or can make a series of tool calls in order to help solve more complex problems. Here's a simple math problem, but it's one that's going to require the LLM to make a few different tool calls to solve. It's going to need to make two additions and then multiply the result together. Let's see how it does it. It got the right answer, but let's look at how. The first thing it does is make two parallel tool calls to the addition function. That's kind of cool. Instead of having many turns to process this, it's realized that some part can be done in parallel. It will send those out for processing at the same time, and this will result in fewer overall rounds or turns with the LLM, which should improve performance and save costs. Once it has those results, it can perform the final multiplication and return an answer to the user. It's a simple example, but it shows how the LLM can mix parallel tool calling for speed and serial tool calling to perform tasks that require multiple steps to give you a final answer. All right, now let's jump into the practical advice portion. My first piece of guidance for you is going to be to use models optimized for tool calling. What does that mean? Well, some models have been specifically in their post-training phase trained to call tools, both the syntax of the tool call and making the right decision on when to call tools. Let's go back to our original example. Calling a function like this that might not seem like a difficult task for an LLM. But unlike a creative writing task where maybe swapping word order or changing a slightly different sentence structure might not matter, function calls need to be extremely precise. You can't swap arguments, you can't say capitalization, the syntax has to remain exactly correct. So models that have been post-trained for tool calling are much better and more accurate at this task and are going to have a much higher success rate with tool calling. Now, the obvious next question is, how do you know which models have actually been optimized for tool calling? Well, the official ways to check the model card. Here's Qwen 3's model card and Hugging Face, and you can see it specifically says it's been designed for precise integration with external tools. But you probably don't want to go check a dozen model cards to see if it's been trained for tool calling. So there's an easier way. At Kiln, we've written over 3,000 capability tests for LLMs. Each week, we test which models on which providers have which capabilities. In our model library and app, you can select the dropdown, select the tool capability, and see a set of models that have been pre-vetted to work with tool calling. Sometimes the same model even varies from provider to provider based on the quantization they use and if that provider provides constrained decoding for tool calling. And Kiln will help make sure you don't make any mistakes. For example, let's add a tool call to this task, and you can see it's immediately highlighted that we're going to have a problem. This model doesn't support tool calling, but I can select another model, and that warning goes away. All right, now here's my second piece of advice. Don't add too many tools to your AI system. That can seem counterintuitive. Tools give your system more capability and more power, so adding more tools, more powerful, more awesome, right? Probably not. Let's look at an example. Here's GitHub's MPC server. It's actually incredibly powerful. It lets you add comments, merge, manage PRs, and do a lot of other tasks. But there are over 60 tools. If we were to add all these tools into the task, it has to inject the function names, the description, the argument names, the argument descriptions into every single call we make, adding an absolute ton of information to our model's context. Adding all of that data means more tokens, which means it's going to be more expensive and it's going to be slower. It also means you're dividing the model's attention. It's going to be able to focus less on the prompt because it has to process all of these tool calls. That dilution of attention means it might get worse at actually processing your task, and the whole time all this information is going to be filling up your context window. The easy fix is to just give your task access to the tool it needs. This will make your task faster and typically better. If your task really does require dozens of tools, it can be worth exploring dividing into subtasks with related tool groups. For example, you could have one subtask with the GitHub commands, another one with Firecrawl that can search and scrape the web, and a third one for performing math. You can build and evaluate each of these tasks separately, and then evaluate overall system performance with an agent that combines them at the end. Let's cover an example of how this architecture can really help keep your context window clean. One of the things we talk about more and more in LLMs is context management. Picture a web research task, something where you can ask a question, it goes off and looks at the web and brings back a result. It might make 5 web searches and read 17 web pages and do a ton of deep digging to get you a nice summarized answer. Now, all those requests and all those web pages probably add up to tens of thousands of tokens. If all of that goes into your context for your upper level task every single turn, it's quickly going to get its context window filled and it's going to be diluted with a bunch of irrelevant content. Whereas if we have a subtask doing our research and providing back just the summary, the context window of the overall agent stays nice and clean and tidy. It's a good way to separate things and keep your context window clean. All right, and that's tool calling 101. We covered what tools are, how to add them to your system, and some basic guidance for integrating them so you don't run into roadblocks. That should be enough to get you started and build some pretty compelling AI systems. However, if you want to get more advanced, there are more advanced topics to look at. For future videos, we're going to talk about evaluating tool calls, making sure the right tool is called at the right moment. We're not ever calling the wrong tool. We're going to look at building custom tools like a RAG system. We're going to look at fine-tuning tool calls, because remember we talked about how post-training can help models be better at tool calling? Well, you can actually fine-tune a model to your specific set of tools to make it even more performant. And finally, we'll talk about building agent systems. So if any of these topics are interesting you, you can either join our mailing list at kiln.tech/blog or subscribe to our YouTube channel. And if you want to try this yourself, the Kiln app is completely free. You can download it on our webpage, kiln.tech, or from GitHub. Thanks for watching.